So in this video, I'm going to manually apply Euler's method in order to solve a differential equation. So the one that we're going to try and solve is y dash is equal to 3y plus t, and we're trying to get it up to t is equal to 0.3. We're given the initial condition, and we're told to use a step distance of 0.1. So I've copied across the Euler's method equation. So this states that y at t plus h is approximately equal to y at the previous time point plus h times the gradient at the previous time point. Now, of course, the gradient at any point in time can kind of be calculated with this equation here, which is what we're trying to solve. So if y dash, I'll put it of t, is equal to 3y plus t, rather than writing it this way, what we can do is say that this is the same as being a function of both the time and the y value at that point in time. So I can then write this as 3 times y as a function of the time plus the time. And this is just going to help us prevent getting confused as to what time we're actually referring to in the equation, because we're going to end up with some future times and some previous times appearing. So let's start off by looking at the initial condition. So that's telling us that at time is equal to 0, the y value is equal to 2. So y of 0 equals 2. Alright, so now we're going to try and apply the method in order to project to the next point. So at t plus h, alright, our next point in time, we can figure out what that is. It's going to be 0, alright, plus the h value. So we should be able to predict what's happening at time of point 1. And we're going to apply this equation to it. So y of point 1, okay, because that's the left-hand side, is equal to y of t, which is going to be the 0, plus the h value times y dash of t. And we're going to replace it, instead of writing it like this, we're going to write it like this. Okay, so 3 y of t, again t is 0, plus t, which is 0 again. So let's substitute some numbers in here. So y of 0, that's at the previous time point, which is 2. H is 0.1. Y of 0, that's again the 2. And we already said t was equal to 0. So if you substitute all of this into a calculator, you end up getting 2.6. So it's probably going to be worth us giving a sketch so we can visualize what's happening here. So if I've got t and I've got y, at t equals 0, y is 2. So let's say that's this point here. And then what we've just calculated is if we take a step across of 0.1, this of course was 0, we've ended up with 2.6. So that's the next point in our sequence. Oop, let me draw it in green. Alright, so our aim here was to get up to t is equal to 0.3. So let's go again, taking another step forward. So we're going to the next point. So what we need to draw in is the previous one, which was 0.1 plus h. So this is taking us up to 0.2. So y of 0.2 is going to be equal to, again applying this Euler's method, y of the previous point, which was 0.1, plus h times the gradient at the previous point. And again, we're going to draw in this notation for it. So 3 times y of the previous point, which was 0.1, plus the t of the previous point, which was 0.1. So we can substitute some numbers in here. Y of 0.1 we just worked out to be 2.6. H is 0.1. Again, this is the 2.6 and 0.1. So if you type this one into a calculator, you end up getting about 3.39 for the answer. So again, visualizing it, we've taken a step 0.2 and we've ended up with 3.39. So that's going to be somewhere up here. Not sure that this is particularly to scale, but anyway, something like this. Alright, so we're trying to get to 0.3, so we need to go through one more round of this. Okay, so at the next time point, so we need to add on a h value. So 0.2, plus the 0.1. This is taking us up to 0.3. So we should be able to estimate what's happening at 0.3 based on what was happening at 0.2, plus h times the gradient at what was happening at 0.2, which we can write as 3 times the y value at 0.2 plus the t value at 0.2. So substituting in, we get 3.39 plus 0.1 multiplied by 3 times the 3.39 again, plus 0.2. And this one works out to be 4.427 for the answer. So again, if you wanted to pop this onto your diagram, everything is a bit high here. Let's shift it all down. All right, so it's something up here. What was it? 4.427. And it's going to be somewhere up here for the next point in the sequence. All right, so that's pretty much what we were asked to do, since all we were told to look to was t equals 0.3. So using Euler's method and a step distance of 0.1, this is our estimate for what y actually is at that point in time. So in the next video, I'll look at how we can compare this to using other step distances and also using other techniques.